You may have thought once or twice in your life, how does food really turn into energy in our bodies? It follows a process called cellular respiration, which has 3 steps: glycolysis, the TCA cycle, and ETC. But we're not going to focus on all the steps. We're just going to talk about our friend PDC. PDC is an enzyme that helps us get from the process of glycolysis to the TCA cycle. It takes the byproduct of glycolysis, or pyruvate, puts it in the enzyme PDC, and then turns it into acetyl-CoA to go into the TCA cycle. What does PDC look like? Meet our friend, PDC. It really just looks like a big bumpy ball. However, it's more complicated than that. It has a core made of a bunch of E2 proteins, and then off of that core there's a bunch of arms that can swing to different places. Around the core there's a bunch of surrounding proteins that help the reaction. So how does PDC even work? Well, one of the surrounding proteins takes pyruvate and turns it into acetyl. Then a long arm from the core reaches out and grabs that acetyl and turns that into acetyl-CoA, so it can give it back to the mitochondria for the TCA cycle. But to keep the reaction going in PDC, the E2 needs to get rid of an H2. So he takes his long arm and gives it to another surrounding protein so that he can add it to an FAD, which then also gets added to an NAD, which can be given back to the mitochondria for other reactions. So what happens when PDC stops working correctly in your body? Well, first, you don't get enough energy to your muscle cells, so you can have hypertonia, or a lack of tone in your muscles, and weakness in your muscles. Then, you can have weakness and problems in your heart, and your heart tissue can end up dying from lack of energy. You can also have neurological problems such as seizures and other abnormalities caused by not having enough energy. Sadly, a lot of these patients die because they don't have enough energy for their cells. However, scientists are still trying to figure out better treatments for these PDC problems.